and then to go ahead and evaluate. All right, the next thing is find the domain and range of the following function, y is equal to absolute value of 7 minus x. So there's a couple things that we need to understand here. First of all, the parent function. All right, so this is something that we're going to learn in my class that I tell students all the time. If you see a function and you're asked to graph it or identify any characteristics, you need to know what that function exactly looks like. So here's the absolute value function, over 1, up 1, over 2, up 2. Left one has the same properties. This is the lovely V-shaped graph because it looks like a V. Okay, so automatically from understanding this parent graph, we can recognize a couple things. The domain here is going to be all real numbers, right? Because this graph expands to the left and to the right. And the range in this case is going to be from 0 to infinity. Again, make sure 0 is included, right? And then it's going up to infinity. All right, so now moving on to the next thing, we need to understand the transformations. What is this doing to the graph? So there's a lot of different ways we can go ahead and understand this. Before we can go ahead and do that, what I tell my students to do is rearrange everything so it's in the format that we can identify everything. So first thing I do is I rearrange this to be a negative x plus 7. And then we talk about c and b, you have to factor out that negative. So therefore, this is in the form negative x minus 7. And this is very, very important to understand it in this regard. And what we notice is there's only two transformations that's going on. We're multiplying by negative. Our x is being multiplied by negative, and then we're subtracting by a 7. So we need to understand what those transformations are. So to understand those transformations, we need to know the generic transformations to any function. Well, we can just use our parent function here and just say all the transformations are a times b x minus c plus d. So these are all the transformations. If you're unaware of what A, B, C, and D do, I do have notes on them, but I definitely make sure that you are comfortable understanding. Quick little review. A vertically stretches or compresses the graph. D vertically shifts the graph up and down. B horizontally compresses and stretches the graph, and C is what shifts the graph left to right. So these transformations are all the same. It doesn't matter if it's an absolute value, if it's a quadratic, if it's a cubic, they all impact the graph the same. The only thing that changes is really the function, absolute value, square root, whatever the type of function is. So the main thing though is I had to if you leave it like this, a lot of people will make their mistakes and they'll leave it in this formation where really you need to put it in this formation to really truly understand not only the b, because the b didn't change, but you can see when I factored out the negative, the c went from a x plus 7 to a x minus 7. Very, very important to understand, because again, you can check my work here by just plugging this into Desmos and seeing how the graph gets transformed. One thing I forgot to mention, when A is negative, that's reflected about the x-axis. So therefore, when B is negative, that's going to be a reflection about the y-axis. So let's just write down all the transformations. So we're reflecting the y-axis, and we're going to the right 7 units. So remember, when it's that 7, it's x minus c, right? So it's like x minus c, or x minus c. Right? So c in that case is actually positive, right? When you do x minus 7, 7 is actually positive. That's why it's actually going to the right. The formula is x minus, but therefore it's just some things that you need to understand in that regard. All right, so we have right 7 units, good. Reflect the y-axis, got it. What was I trying to do? Oh, domain range. All right. So now to understand the domain range. Well, the cool thing about this graph is the domain's all real numbers. So it doesn't matter what transformation I'm going to do, the domain is always going to be all real numbers. So that's a cool thing. So you only need to worry about the domain or the range changing when it's restricted, which you can see the range is actually restricted in this graph. So therefore, these transformations could impact the range. But actually they don't, because all of these transformations are horizontal. Right? So if I take this graph, I shift it left and right, if I reflect it, it doesn't matter. Anything I'm doing horizontally is not going to impact the range. The only two placements that would have impacted the range is if I would have had some A's and some D's. Anything outside of the function shifting the graph up or down, or if that would have been a reflection about the x-axis, that would have impacted the range. But since none of those happened, my range is actually the same. So I spent that whole time explaining everything to tell you the answer is exactly kind of the same. But hopefully, if you have a question similar to that,